In this video, we'll talk about what a solution differential equation is, as well as how we can, if given a function, determine if it actually does solve the differential equation that we're given. So a solution to a differential equation is a function that has enough derivatives so that if we plug it in and take all the right derivatives, it satisfies the equation that we're trying to solve. So it's a function, which I'll call phi of t, with at least n derivatives, that if I plug it into the equation, I get a true statement. Less formally, it is a function that solves the equation when I plug it in. Right? How do you verify that a number x solves an algebraic equation? Well, you plug it in and see if it solves it. The same thing goes here. If I have a function that I want to check if it solves a differential equation, I take my function, I plug it in, and I see if I got a true statement at the end of the day. If I do, then it solves, and I'm happy. This first part here, at least n derivatives, is more or less a technicality. Basically, I can't plug a function into a differential equation if it doesn't have the right number of derivatives. Right? If I have an equation with the first derivative, I can't plug in the absolute value function. Right? Because the derivative of the absolute value, at least at 0, does not exist, so I can't plug it in to actually check if it solves the equation because that derivative doesn't exist. So how do we go about verifying solutions? Well, the same way you'd verify a solution to an algebraic equation. I'm going to take the function, take the derivatives that I need, plug it all in, and see what the equation tells me. And if I get a true statement at the end, and I mean a true statement here for all t, I don't mean that it holds for some values of t. The true statement must hold for all t, then I know that I have a solution. If it doesn't hold for all t, I don't have a solution. Let's see an example of this. I want to verify that the function y of t is sine of 2t solves the differential equation y double prime plus 4y equals 0. Now I don't need to come up with a solution somewhere. I'm given a function I want to see if it solves the differential equation. As a quick check from before, how would you classify this differential equation? Is it linear or nonlinear? And what is the order of it? So this is a second order linear equation. So how do we verify? Well, I take my function phi, which is sine of 2t, and I take derivatives. So what's the first derivative here? Well, that's going to be 2 cosine of 2t. Don't forget the chain rule. And the second derivative will be negative 4, 2 times 2, sine of 2t. So that means if I take this and plug it into that equation, I will see then that phi double prime plus 4 phi equals negative 4 sine of 2t plus 4 sine of 2t, which is 0, which is what I wanted. And that holds for all t, which means then that sine of 2t is a solution of this differential equation. And that's the entire process for any of these verify type problems. All you're doing is taking the function you're given and seeing if it solves the equation. You're not solving it, you're not coming up with the solution out of nowhere, you're just saying, okay, does this function work? Let me plug it in and see. That's the idea of solutions to differential equations, what they might look like, as well as how you go about verifying that a given function solves a given differential equation.